So in this question here, we have a scatter diagram which shows information about 12 girls. It shows the age of the girl and the best time she takes to run 100 meters. And then below we have the scatter diagram. So we have age in years on the x-axis and then time in seconds on the y-axis. Now for the first part of this question, we're asked to write down the type of correlation. So correlation between two variables basically is a way of showing how the two are related. So how time in seconds relates to age in years. And as we can see here, as the age is increasing, as the x values are increasing, the time in seconds is going to be decreasing. We can see this negative gradient here. If we were to draw in a line of best fit somewhere down here, there'd be a negative, it would have a negative gradient. So here we're going to have a negative correlation. So as one of the variables increases, the other decreases. Now in the second part of the question, we're told that Christina is 11 years old and that her best time to run 100 metres is 12 seconds. We're told that the point representing this information would be an outlier on the scatter diagram, and we're asked to explain why this is the case. Now, the kind of definition of an outlier is we're looking for something that doesn't fit this this trend that we have here, doesn't fit this negative correlation that we've already seen, and doesn't kind of fit in with the other points and the correlation of the graph. So if I have a look of where this point is going to be, if she's 11 years old, we're going to be at this point on the x-axis, and she runs it in 12 seconds. So the point is going to be drawn in here. And as we can see, if we were to draw a line of best fit over here, showing this negative correlation, this point lies nowhere near the line of best fit and doesn't continue the trend. So to explain why this point would be an outlier, we simply need to write something along those lines, so it's not in line with the trend of the other points, or that it doesn't fit the correlation that we've already spoken about in the first part of the question. We would also get the mark for saying it's far away from the other points or far away from the line of best fit. So now in the final part of the question, we're told that Debbie is 15 years old, and that Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 metres, and we're asked to comment here on what she said. So if I have a look at the age of 15 years old, and go up to about where we'd expect the kind of general trend to carry on to, it would be something somewhere here around sort of the 12 second mark. However, as the points finish here, so the oldest person is somewhere between 13 and 14 here at this point, this is what we know, this is what is known as extrapolation. So we're extrapolating the data and going beyond the points which are shown on the graph. So this can't be said that the results are reliable beyond this point. So the point at which somebody is 15 is going to be outside of the range of the scatter diagram. So we can't really use it to predict how long it should take a 15-year-old. We can't be sure that this trend is going to carry on in the same way that it already has been. So I'm just going to say here that the point would be outside of the original range of the scatter diagram that we have above. And this means that we just can't reliably extrapolate or extend this data to come up with a value that, come up with a time that it should take somebody who's 15 years old to complete the 100-metre race.